So again, sorry to messed up the beginning, but we're talking about final, which is a constant value, a value that will never change throughout its lifetime. So the moment it's been set to 3.1415, we don't want it to be able to change. So again, just to make sure everyone who's on the video, we can't go ahead and do this. Pi equals 23, it'll give us an error saying cannot assign value to final variable pi. And this is important. And again, this restriction is just for us humans. So if someone else is working on our code, or even for myself, I don't want to mistakenly, by accident, by whatever issue, to change the value of pi. But we could always use it. So if we wanted to get int or float or whatever area of circle, we would put in pi with the calculation, like it's 2 times pi divided by whatever. I don't know really the formula, but this in this case it's because it's an integer. In this case the pi is still being used, but I cannot change the value of pi, right? So this final keyword is a bit is useful for us coding, right? And again, it comes down to cleaner code where we're specifying if this variable should be changed or not. And one last thing you would notice is whenever you have something that's constant, you would capitalize all the letters, such as, actually we've seen this before, integer max value. Notice the max value is all capital. This is because max value is a finalized, a constant value. Integer's max value will never change. It's always going to be 4 bytes having the same value, right? So if I hold down control and I click on max value, we'll go in somewhere where it says final int max value, which is the hexadecimal code for how big it is, right? This final keyword is really important. Any questions? And notice that we have another final character array, digits. So these are the types of digits that's possible. Well, all of this, but all possible characters for representing a number as a string, right? Anyway. Any questions? So constant final, this is really important. This is the constant inside C++. You might have seen this as const. Depending on the language, the syntax is going to be different, but it's always going to have the same stuff in there. Okay, so this is important. So actually, I'll put this inside of a cout. So value cannot be changed, never changing. Variable name must always be capitalized. Again, it's a standard, a convention that we have for the variable names. You don't have to do it that way, but if you don't, I'm probably gonna fire you, as an example. It's a true example. It's because if I see you not doing it, basically means you don't care. Constant variables. Cool. That's that. And I misspelled constant. Let's refactor, rename. Cool. Cool. So that's done. Okay. So no questions? Okay. So let's get to class. Actually, before we do class, well, actually, this is going to be the start of class. So there is 2 things that we learned. Hopefully you learned it, and hopefully you understood it a bit, or you might have forgot it. It's that when we're calling a function, you see all of these functions, and this could come out inside the interview questions, okay? But most of the times they're gonna get this wrong, but even the guy who's interviewing you. Hopefully I'll make you understand what it means. And again, as always, you take it with a grain of salt. Basically, whatever I say, go and do your own research, All right, find those resources that they're top quality people. Don't go find another kid that's trying to teach you. I'm already that kid for you. Okay, um, try to find these industry powerhouses, these guys who are the leaders, and read their stuff or find that information from them. Because what I notice is everyone's wanting cash. They all put out stuff online, and a lot of you, probably a few of you guys, are also going to go right away create some YouTube channel and put some information or go on some medium, and it's perfectly fine because you want to make cash and you have some knowledge. But the problem is, a lot of times the knowledge is not fully clear in our minds, and or we learn the knowledge wrong. And when you're going online, there's a lot of that. There's no real filters. There's nothing that says this guy is good or bad. I've seen teachers telling me wrong stuff and they believed it as if it was their core. So there's no real person you could trust ever. The only person you could trust is yourself. And one thing you would tell me is, well, sir, if I don't know anything, how can I determine who's good or who's bad? This is, you got to figure out where you're finding that information, first of all. Secondly, well, actually, let's go back to the first one. If you find that information into like a open discussion room, you're always going to get more of the correct answer than the bad answer. A good example of that would be Stack Overflow, right? When you go to, let's say, a question, let's say one that has a lot of, let's say, sorry, I don't usually go like this. Top questions, no. Give me normal questions. Stack Overflow. There we go. Okay, let's go to something that has bounty. Okay, whatever. Let's check that one that has multiple answers. Actually, this. So, in this type of layout, in this Stack Overflow, you're gonna start using this a lot. You have the guy who's asking the question and a bit more details about his question. Now, right under it, we have 4 answers. This is the first answer. You'll notice he has 1 upvote, so you can upvote or downvote, and you could comment on his question. Same thing for this guy, same thing for this guy. And I was trying to look for, so let's say this guy who has no upvotes, you kind of understand that maybe this is not the correct thing to do. Or maybe he has it right, but he doesn't completely has it right. And usually people would comment on it, negate it, and I want to find you one that has a lot of negation, but it's hard. 43, 24, you see, like, the better answers are always going to get upvoted much higher, and hopefully we'll find one that's negative. So like this one, just store the current time and exceeds 30 minutes, blah blah blah. So the guy is even saying the only time you evaluate that is when you're using the session, right? And it's kind of, this answer was completely wrong, and you kind of could see the guy's reputation. Narendra Sharma is starting out. He has a low amount, etc. Some people never answer. That could happen, like this guy, or let's see, one of the top answers usually. See, like these are super high values. This guy is not so high, right? Again, not so high. He still has a high rating for that answer, and this is important. So if you, first of all, if you look it into the correct place for your answers, and here rather than, let's say, YouTube, or rather than, say, Medium, this is another place I see anyone post anything and no one cares, you will find better solutions. And the second part is, over time, the information is going to be more clear. As you learn things, you start understanding, well, that doesn't make sense because in the foundation level I learned this, and what you're saying is completely opposite. As your knowledge gets bigger, you could determine if this answer is stupid just by reading the first few lines, and this is a key factor that we're trying to develop. And as soon as you get that, that's when you're kind of mid-level. Anyway, again, stop me whenever I go overboard, off topic too much. So yeah, sorry, I have cat hair in my mouth. I don't remember why I was going there, but let's go to the next part. So before we start the classes, and this is really the last time I'm actually going to do this, before we start classes, I want to talk about this thing that comes in interview questions. Actually, I'll put it inside here. So the term pass by value or pass by reference. Now this is a question that you're gonna be seeing inside interviews. Really, just for the low end companies. If you go for high end, this is like a already must. It's not even a question. It's if you know it or you don't know it. Pass by value or pass by reference. So the first thing we need to understand is what is a value. A value is gonna be something like this: 23, the character F. Let's say a string of character. Actually, this doesn't exist because remember we're talking about primitive types. So 23, true, blah blah blah. Anything that is primitive, right? The value of it, that would be value. In the case of reference, and we talked about this. This is also key termed as pointer. As this is the location in the memory. So we're giving a reference, a pointer, an address of where that value exists. So we're not giving the value directly, right? So these are the two things that we're talking right now: value and reference. And again, I put reference, pointer, address because you'll see it interchange between all three, but they're really the same thing. There's a bit key difference, but it doesn't matter. So if you remember when we talked about objects, or OOP basically, OOP objects, we determined that everything is an object except for primitive types. So whatever you create, such as scanner, is gonna be an object, and we're gonna talk about this a bit further. But the key thing to understand here is that all objects, all of them, you don't actually have the value. All of them are references to the location inside the memory it exists or inhabits. So all objects are somewhere inside the memory, and that memory would be the heap memory. And everything else would be inside this stack memory. So everything that's passed by value would be in the stack. Okay, we're gonna look at this in a second, and then we're gonna come to pass by value, pass by reference. So what I mean by this is if I create an integer and I say, let's say age, and that's 34, and I say let's say let's say the sex, let's say it's male, and for that and let's create, well, let's say that. So when I create these two things, these two variables, they're primitive type, right? Primitive as in they already exist inside the OS or inside the compiler, whatever you want to call it. There's one that's integer and one that's character. And this is important to understand primitive types because primitive relies on the OS. So sometimes this integer, well, not in Java, but let's say in C++, if you go from one system to another system, the size of the integer could be different. Okay, but in case of Java, it's always going to be consistent. So now, if I create integer or character, or actually, before I even say that, when I create an application, the application inside the memory, inside the computer, is going to be given two things. One, it's going to be given a stack. And the second thing it's going to be given is a heap memory. And the naming should you should get used to the naming. This naming is a bit easier to remember. The heap is a bit harder to grasp, but the stack is a stack of things. So think of a stack of books. Think of anything that you could stack somewhere, right? So that's a stack, and we're gonna see how it works. The heap, it's a range of memory where the computer has given for Java, and you get allocated somewhere in there, right? So sometimes the heap is shared with other things, so you might have your let's say Chrome or Zoom running as well. So Zoom takes all of this memory, and Chrome is somewhere in there, etc., etc. All the other applications. So this space in there is not perfect. So you can't just write one thing after the next like you would do a book. The places that are open is different sizes, and this is because, let's say this application over here, Chrome, take a lot of spots, right? So then the next apps are gonna be here, and then here, and etc. Right? But at some point, Chrome, you closed it off. So now Chrome is erased, but now we got a void, empty space. And this is why the heap cannot be a one after the next allocated memory. And again, this is for OS and whatnot. We're not going to talk about it too much. Just understand that this is randomly allocated, and we can't make it one after the next. Some applications will try to do that, but again, different topic. Now, we're giving a stack and a heap for every application. So when I run my application, when I press this little run button, I'm given these two things to manage or do whatever I need to do inside my application. Now, whenever I create a variable such as age, such as the character sex, in those two cases, they will be added to my stack. So let's do try. So over here, I add my age and my value. And this is easy because the size of these integer characters and whatnot is always known. So this is an easy way to stack up. So the first thing I created was age, 34. The second thing was 6. And that one, the value is M. Okay, and we could store it inside the stack, and we don't need the heap for this. And again, I'm giving you a broad definition. As we go deeper in this, the stack and heap, you'll notice it starts being a bit different. But for now, as the early stage, take it with a grain of salt. This is how it should look like. This is pretty good. Okay, so because they're primitive type, I could just store it in there, and whenever I need to reference it, I could just come and grab it from the stack. Okay, so now when I create a function, let's say public static void something, okay, I can't think of a word right now, and let's say I pass in an integer and I pass in the character again. Right? When I do this and I call this function, and let's say I do a cout print age plus sex, and then let's say I change the age to equal, well actually let's just start with this and we'll continue after. And let's say I do, let's call this one our print, so it makes it a bit easier. So print 34, or actually we're going to give it the age and the sex. Right? So if I run this, the only thing it's going to do is print out age and sex. 34. Perfect. Everyone's good? Let's go a bit more funky. And let's say inside here, I go and I change the age to 24 or 23. And then let's say I print it out here. Oops, system out. Age plus that plus X. And then I also go ahead and I print it out here. So let's say here and here. to say before. And I'm going to say after. Okay? So if you look at this code, you'll notice there's a variable age and a sex, and I pass it to this function. Inside that function, it prints them, but then it changed the value. Now, does this changed value change it here in this scope, or does it just stay in this scope? So, in this after, would it print 34 or 23? That's the question we're trying to figure out. So if we press play, we'll notice that it's not going to change, even though it's changed inside. So before, that's this line, 39. Inside that function, again, remember one line at a time, so this function must finish before it goes to line 41. We print out line 47, the age and the sex. On line 48, we change the value. Line 49, we print it out again, and you'll notice it's changed. But when we go outside to continue at line 41, notice the value hasn't been changed. And this is because functions are always going to be this thing we call pass by value. And this pass by value actually means pass by copy. Okay? So this thing, the parameters, these two values given here, is passed by value, which basically means make a copy of the value and send it. And this is perfectly fine, because the cool part is if I send it to someone like the print, they can't change my variables. They could only have a little copy of it. And this is what pass by value means. Does this make sense to everyone? This is an important factor. You're going to have this as an interview question. Okay, and all primitive types by default, they're always passed by value. Now, oops, let me just get some water. 1 second. Now let's make this a bit more interesting. So far, we've seen two things. We've seen actually a couple things. We've seen the scanner. We said this is an object. And all objects, they also get created. So let's talk about the scanner 1 second. All objects also get created on my stack. 1 second, draw this. Okay. So my scanner also gets created here. So this is my scanner. However, the problem with scanner, because it's an object, we don't know the size, and it's not a consistent size, let's say. So it needs to be allocated in the memory where it's bigger, where they have more space to do whatever the thing they need to do. So scanner, even though we have it on stack, this is the value that we have here is actually the address. So the value stored here is the address. So this is the address. So this, the scanner actually somewhere inside the heap, and this is an address to that. Right? So this is an address. So this is what we call a reference. So this is the actual scanner object. All the stuff the scanner needs is in here. Okay? But the actual variable that we have here is an address. An address is always going to be a exact size, right? Just like the integer and the character, an address is going to be the size that allows me to see from this location to this location, right? It's going to be a value that shows me the range of the heap, a value that shows me all the addresses. And this is why, as an example, you have Windows 32-bit, and now we got to the point where our Windows are 64-bit, and the next one is gonna be Windows 128 bits. Why? Well, this is the range of the memory. This is the range where the memory size is. So these are always gonna be consistent. There is that much size for the addresses to store in the memory, right? And as we get bigger, will require the next big thing. So the Windows, when they transitioned from 32 to 64, it was a big movement. All the code needed to change and whatnot. And you would say, well, why not we just go to the maximum? Well, we can't go to the maximum because after this range is kind of empty and we'll just start creating issues. There's a bigger thing going on there. Again, take it with a grain of salt. But this is what the 32, 64, and all that stuff means all the time. Anyway, so let's go back here. So, having that said, give me a second, having that said, the scanner is a specific size, okay? The sex is specific size, the age is also specific size. So they could stay in the stack, it's easy. But the scanner, again, it's an address to somewhere it is. Now, when we created an array, it's the same thing. So let's go ahead and create an array. Int array of, let's say, your grades. Again, plural with S to say your grades. 34, 25, 33, I don't know, 1, 2, and let's add one last one. So now, grades, if you think about it, again, grades over here is gonna get created on my stack. It's gonna create it on my stack. Grades. Sorry, 1 second. Yeah, that was bad. So grades gets created, but again, grades is a location because this array is actually too big for the stack. Okay, the stack is a constant size for each values in there. So this grade is gonna get created somewhere in there. It's gonna find the space for 5 integers, right? So the size of 5 integers would be 5 times the size of an integer, which is 4, which is 20 bytes it needs. So he goes, finds 20 bytes and gives it to it. So we have our first, second, third, and fifth. So all 5. So here we got 34. Just to make sure you guys are not lost. 25, 33, 12, and 56. Right? And now this grades, again, it's an address. It's gonna go ahead and point to here. Right? So again, this is an address. I'm sorry for my handwriting. If something is not clear, let me know and I'll clean it up a bit more. So this is the grades. Actually, this is a bit ugly. Maybe I'll use the text thing. Grades. Yeah, that's not bad. Okay. Any questions? So far, this should make sense. And what we noticed was when we call a function, we pass by value. So a copy was made. Right? So only changes the copy and not the original. Now let's go a bit further. Public static. I'm going to keep the print there so you understand. But now we're going to see something that people confuse. Change some grades, okay? And what we're going to do in there is we're going to pass in our array of grades. And again, this name could have been anything. We could have called it whatever. It doesn't really matter. And inside that grade, we're going to do, again, I want to print the whole array, but I'm a bit too lazy here. We're going to make a new function just for the print, so here we keep it clean, okay? Public static void print array. Okay, int array. And inside that, we're going to do a for loop. And position equals 0. Position is less than array.length. And position. And all I want to do is print our array. So system. And what we're going to do is array add position. and we're gonna put a little space afterwards so they'll print out each after each. And then at the end I'm gonna just also do a new line. Cool? So here, given the grades, I'll do a print array and pass in that grades, right? And then I'm gonna go and change a value, grades at position, let's say 1, that 25. I'm gonna change that value to 99, an easy, remarkable thing. And then I'm gonna say print array grades again. Everyone's clear with this? Now this array that I'm given here, actually, you know what? Let's grab that thing and put it here. Now this grades that I'm given here, I'm gonna do the same thing, before and after. So I'm gonna do a before. And this time, because we have a function that prints that for us, we're gonna just say before, and I'm gonna say prints array grades. Then I'm gonna call this function, change some grades. So here, so you could ignore the parts at the top. I'm gonna call change some grades, pass in our grades, and then I'm gonna say after, where I'm gonna print the array. Okay? Now, look at this code and tell me how is it gonna print. So after it changes the grade, is the after gonna be the same or is it gonna be the same? Is it gonna be the same or is it gonna be different? Any opinions, guys? 1 second, I can't hear you guys. Maybe I'm on the wrong output again. Can you talk again? Yeah, I can't hear anything. 1 second. Try now. What's going on? 1 second. Volume's there.
Disconnected?
No, I have multiple outputs, so it messes up. Give me 1 second, guys. Realtek audio second output. Realtek audio second. Okay, can you try again, please?
Hello?
Yeah, now I could hear you. Sorry.
Yeah, sir, it's gonna be different because we are kind of passing the address.
Okay, so yeah, well done actually. So remember that when we talk about grades, that's actually an address. So when we when we send it over here, this guy has an address, and again, it's accessing that location in the memory at position 1. So here we're actually changing it on the heap memory, right? So this is a part that's gonna be a bit confusing, but actually first let's play it. Good job, by the way. So notice our values here. Forget there we go. We don't care about that. So before we start out 34, 25, 33, 12, 56. In the middle, it's still the same, so this part. Then we change it to 99. We print again. That's this line. And after, when we print, it's still the same value. And this is because, like he said, we're actually passing the address of where it is. And this is going to be a bit funky, right? Look here what happens now. Tell me if, again, it would change. So in this case, I say grades equals a new array. Let's say this time the values is 1, 2, 3, 4, and 5. It doesn't let me do that in Java, huh? Here we go. We could do this. Cool. So in this case, I'm redefining the array, and we'll keep this part, but now that we changed the whole array, what is it going to be displayed here? Before, middle, and after. Can you guys take a second to think about this? And this is the funky part. Anyone wants to give a guess? A guess is perfectly fine. We want to just take out the doubts. Now it's becoming funky, right? So inside this after, would it be printing 34 and all of this, or would it be printing 1, 2, 3, 4, 5?
So in change some grades, we are giving a new address to the grades.
Yes.
So
Inside line 56.
yeah.
Okay.
So I think when it goes out of scope, it will like fall back to its previous address in main.
Okay. So here it
Yeah.
would print what?
So I think it would print 34, 23, 33, 25, 33.
Okay.
Because in here changes some grades, we are kind of giving a like new address to the grades.
Yes.
And
Remember here. Okay. You got the right answer. Let's run it. So what he says is at the end it's going to be back to this number, and he's correct. Right? We're back to 34 even though we changed the values. Well, you're going to tell me, well, how come this one stayed previously, but this time we changed the whole array, it doesn't stay? Well, this is where people make mistakes. You got to remember that our functions are always passed by value. This is something that everyone makes a mistake on. And in the interview, the guy might interview you and he's going to say, if I send an array, is it passed by value or passed by reference? And you're going to say, it's always passed by value. But the guy's going to say you're wrong and you're going to get into a fight. And you could tell the guy, well, you're a dumbass. And I'm going to explain why it's always passed by value. And this is a big mistake everyone makes. This is always a copy. Anything you send into a function as a parameter, it's always a copy. So in this case, if you notice here, this grades, which is an address, we copied it in here. So there's a second guy, this guy, who also has the address to this, right? This is also an address because it's passed by value. Every time it's a copy of the value being the address. So this guy, let me change the color here, is not the same guy as him. So you could think of it as I have two documents showing the address of where, who was it that was talking? Harmanpreet. I have the address of Harmanpreet in both documents, right, where he lives, but in one document I changed the value, and the other one, well, it stays the same because I'd never changed the value. So even though we're copying the address, we don't actually have the direct variable that was giving the address in the first hand. We don't have this grades, right? So in this case, when I change a value at that address, well, they're both looking at the same thing, right? If you want to think about it as a, let's say we're both looking at our screens, right? We're both looking at our screens and I change something on the screen. Well, we're both seeing the same thing. But anything not related to the screen, well, you won't see it. So if my eyes are actually now looking at the roof or the ceiling, look at the ceiling, well, no one else knows about this. And whatever I do drawings in my other screen, so I'm outside, you guys can't see that either. Why? Well, because we're all looking at this screen right now. But if at any moment I change, well, you guys won't change. It's the same thing here. We're just have a grade and we're copying what the grades is looking at inside here. So they're both looking at the same thing, which is this, right? Let me change the colors. We're both looking at this guy, right? So notice this arrow and this arrow. This is what was created inside main. This one is also created, but it's looking at the same thing. And if any of them does something on the heap memory, well, they're both looking at it, right? It's the same if I have two files that are showing the location of where Harmanpreet lives. Well, if I go and I paint Harmanpreet's apartment, well, Harmanpreet will see the apartment painted, right? If for some reason, let's say his house burns, well, we're both gonna see his house burn, right? But if any moment I start, well, let's say I don't go to his house and I go live somewhere else, well, whatever changes I do to mine is gonna affect mine, but his is gonna stay his because he never moved with me. I don't know if I'm making this more confusing. The fact being, the moment I did this new keyword, what happened was, this changed to a color we didn't use yet. The moment I did this new keyword, this one started pointing out to somewhere else in the memory. Right? And in this case, it had 1, 2, 3, 4, and 5 at the initialization. Obviously, later we'll change it to 99. But the moment I did this new keyword, we created a new location in the memory, and this grades is the address of that new location. So even though this one changed, you got to remember that the only thing we copied, the only thing we passed by value was the address of where it exists in the heap memory. Right? Does this make sense to you guys? And this is important. This is something people make a lot of mistakes on. So sometimes you might hear someone say arrays and objects is passed by reference, but it's not. It's actually passed by value. But the reference inside allows you to modify something on the heap. And this is a bit confusing. This is a bit the hard part to grasp. This will come over time. Any questions? And this is the reason that afterwards my array is not changed. Because this created a new array, but this still points to the old one. Even though a copy of the value of grades has been put in this, it still points to the old one. It will never change.
Hello.
Yeah, what's up?
So like we make an integer variable using new keyword in main, and then passing it to some function to
Yeah.
change its value.
Yeah.
So sir, it will more like pass by reference in other languages like C++.
No,
It will change.
it's always passed by value. It's a copy, but these both of them, they're holding addresses.
Okay.
Does that make sense? Even in C++, they're always the
Yeah.
same. It's just
Sir,
yeah, go for it.
sir, like actually passing a variable to the like function which is created by new keyword, not statically. So sir,
Uh,
will it change the value of the variable in main?
no, again, it doesn't matter if the static was here or not. Okay,
Okay, sir.
this doesn't matter. You just
Okay.
gotta remember it's always passed by value. But over the years, people learn it wrong and they make a mistake, and eventually they named something passed by reference, which is not what it actually does. And sometimes they kind of understand it, but they don't, like, they understand it badly. How would I say it? They got to, like, you got to the correct answer, but the way you fought it was, it was a bit different. It was not the correct solution. And this is okay in most cases because the error is not going to influence anything. But understanding something a bit wrong could eventually dictate some big error, which would crash everything. So this is why we should understand something correctly. And if you want, actually, let me take a screenshot. 1 second. Mouse. Let's bring this back down. Let's take a screenshot of this. Save. Okay. Let's go back to this. If you want, again, don't trust everything I say. Go somewhere. Let me clear the screen. Clear all drawings. Go somewhere and confirm your understanding. So pass by value versus pass by reference. And if you did it in Google, it should be one of the first ones. And look at this one. What's the difference between passing by reference and passing by value? 1,000 votes. And again, the question is this, right? This is what we just did. A parameter passed by reference. Let me zoom in a bit. Maybe that's going to help you guys out. The question is, what is the difference between a parameter passed by reference, a parameter passed by value? Could you give me some examples, please? Blah, blah, blah. So look at this. First and foremost, blah, blah, distinctions are in CS is now obsolete because the technique originally defined by passed by value has since fallen out of favor and seldom used now. Okay, so it doesn't exist. And if you go read this on your own, you'll most likely figure things out. And again, if you go on Google and you type in pass by value and pass by reference in Java or in C++ or whatever, you could see again another Stack Overflow or probably the same one coming up, right? So look into this. It's good to learn on our own. And yeah, so there is no more pass by reference actually. So it's always pass by value. It's just you're gonna have a problem during interviews where the guy still doesn't understand this correctly and they will say, no, you're wrong. It's pass by reference. And if you understand it correctly, you could probably teach him, and it's either going to happen two things. The guy is going to be grateful and hire you right away, or he's going to be pissed off at you saying, who the fuck do you think you are? Sorry for my language. Who do you think you are? You're not going to get the job. Either or is going to, something's going to happen. And to be honest, if he's not going to give you the job for teaching him something, well, you probably don't want to work there. You know, there's a lot of times where people can't take criticism and it hurts. Cool. Sorry, I'm off topic again. Does this make sense?
Yes, sir.
Thank you. All right. So knowing this, that everything's passed by value, and knowing that these are actually references, these are actually pointers, these are actually addresses in the memory and the heap. Let's get to objects. And objects, we already created a few, by the way. One of these objects is called scanner. Another one of these objects is these arrays. There is no such primitive things as arrays, right? They don't exist. It's something we invented to make our lives much easier. Well, obviously we invented everything, but the point is, it doesn't exist in the zeros and ones. Let's say as that, as we go down. Now, let's go ahead and create ourselves objects of our own creations. With objects of our own creations, we get power. We get to do weird, funky stuff, such as like this scanner, without needing to write a lot of code. And again, we don't need objects. We could have wrote everything in main, but it'd be hard to decode and so forth. So the first thing I'm going to do first is let's go ahead and extract this. Refactor, extract to, let's say, pass by value or reference. Actually, I'm going to remove the reference as it doesn't exist anymore. We even read that for a second. You could look into it a bit more. I don't really care that much at this moment in my life. Well, I know it enough that I don't need to care for it. Okay, so now we want to create an object. The first thing we need to do to create an object inside our project, we need to create another class. So what would you like, what would you guys like to create? Actually, I'm gonna kind of take control here. I'm not gonna take your suggestion. Sorry for this, because I want you guys to define what that class is gonna be. So I'm gonna pick a few of these and we're gonna go through them. And the first one we're gonna pick is easily a student. Notice the class should always be capitalized. Why a student? Well, because you are a student and it's the easiest thing that we could start creating.
Hello.
Yes.
Sir, actually, my previous question was, what if we create like an integer variable using new keyword? So then I just searched the internet, like Java cannot allow us to create a dynamically allotted variables.
Sorry, so what you're saying is if I created int like this and I
Yeah,
did it with the new keyword,
actually, sir, and then passing that a to another function.
okay, well, you can create a primitive type with the new keyword because the new
Yeah, sir,
is,
actually that was my like doubt.
but you could create a integer helper class. Okay, and I don't know what it requires in there. It requires nothing, so it should be fine. Or no, it requires a value. There we go. Okay, you'll notice that it's the IDE is saying, hey, don't do this, but you could create a helper class that contains the two, and you could pass this, but now because it's on the heap memory, but this is really going, it's making your life harder for no reason. The only time you're going to use the keyword new is for objects, anything that's not primitive, anything that cannot live on the stack, right? So their size is too big for it to live on the stack. Does that make sense?
Yeah, sir. Actually, now.
So if it's a primitive type, again, it's passed by value, and because it's not reference, well, it's not a reference to somewhere in the heap, well, whatever changes you do, it's not going to affect it. The same way we did changes to the creation of a new reference will not affect the outsider. Okay, and you know the coolest thing from, I don't remember who was talking here, but the coolest thing that you did was you had some doubts, you looked into it, you tried it out. And this is what you should do throughout your programming life. The more things are clear, the easier time you're gonna have when you're programming, when you see things, when you have to do an assignment, a project, etc.
Yes, sir.
Okay, Harmanpreet. Good job,
Yeah.
Harmanpreet.
Thank you, sir.
Okay, so let's get working on our student class here. So let's actually erase this. I don't want this. So this student class, again, one thing to note, each object should be in their own files, okay? Don't have a different object, like don't put all the classes in here. This class only contains, this one file only contains main, the student only contains student. You could have multiple stuff here, public, class, let's say teacher, and it is fine, but it's a bad code to do, okay? So don't do this. And you see here it's giving you, it's actually a warning, but it's enforcing as a error, okay? You shouldn't put them in the same file. And again, you're gonna see this shown here. Again, they don't want you to do that. It's a bad practice. Why? Because it'd be hard to know which file contains what class for us. And if you put 100 classes in here, this one file, again, your code right now is super small, 100 lines, but eventually you'll notice our code is gonna be 10,000 lines and so forth. Okay. So, going back to this. So, we want our classes to be capitalized. Now let's talk about all the stuff that happens here. So again, we're gonna start a little comment thing. So the first thing to understand is inside this terminology, class, you've seen it and whatnot, this is the definition of the object. By definition, you could also think of it as the blueprint of the object. Definition, blueprint, it's the map. I don't know, not map is not the correct word. Definition, blueprint, I had one last word I could probably use. So what I mean by blueprint, definition of the object and whatnot, it's we're defining how our object is gonna be when created. So a good example of this would be if we go on. So when constructors are coming to create your house, they kind of need of a plan, an idea of where the rooms are so they could figure things out. What's gonna be in there? How big is it gonna be in there? When they created boats, when they created anything, at all times we need this thing we call a blueprint. The blueprint is gonna tell us if we need it to be this size, that big, it could do this, it could do that, right? This is another blueprint. A fun one that I like to show to my students would be, scroll down a bit, I can't find it. Let's put, so this is a great example. Open image in new tab. This is a great example. This blueprint kind of gives us an idea of how the sizes are. So this is attributes. How big is his helmet? How big is his arms? How big is his legs? It gives us ideas of the size of the, let's say again, the attributes, the size of the core, and so forth, so on. It also gives us an idea of all the actions it could do. It could throw rockets with targeting. It could rise with hand, blah blah blah. It could power a thing. It could do this, etc. Okay, so a blueprint gives us an idea, and we need these blueprints to create multiple of the same object. We're not always just going to create one. The blueprint is going to define what we're creating, but the values of it could be different, and this is important part. So what do I mean by this? Let's go back to, where were we? I'm going to close these. So the class is the blueprint. Now inside of a class, it's going to contain a couple of things. The first thing is attributes. Okay, you could also use the word. This word is kind of interchangeable. It's the properties. It's the fields. It's the class variables, etc. etc. I like to use the word attributes because this represents who a student is. Okay, and these attributes are the defining. It defines the object. Okay, and you should also, as a rule, put this at the top of their class. At the top of the class. Okay, so attributes again. Think of a student. What defines a student? What are the attributes of a student? Can you guys help me out? Because here I need you guys.
Serial number.
Serial number. What do you mean by serial number?
Enrollment number.
Roll number actually, sir.
Yeah. Every student needs a ID, right? I'm guessing
Yeah,
that's what you guys meant.
Yes,
yeah.
enrollment number, name.
Okay. Good.
ID, age, name,
Good. Okay.
sex.
So ID, first name, last name. What would be the type for an ID?
Integer.
Integer. Yeah. Good. So ID would be an integer that belongs to student. So a student is defined by his ID. So this is our attributes. Okay, so this is the first important thing about a class, an object. It has attributes. Now, so there's a couple things here for ID before we move on. Notice that when a student is given an ID, what should happen?
It should be unique.
Sorry?
It should be unique. It should be unique.
It should be unique. We'll get back to the unique in a second. But it should also not be, you can't have, well, it is unique and it cannot be changed. So what should I do to the ID?
Constant, sir. Constant.
Constant. And in Java, constant is
Static.
Static. Final.
final, not static. Static is something else.
And sir,
yeah,
ID should be in capital letters.
yeah, because it's final, we put it in capital letters. Thank you very much. You'll notice we're getting an error because we didn't assign the value. It hasn't been initialized. So one thing we should note, it's whenever we create any attributes, any variables, to always initialize it. Don't allow it to go to the default because the default could be unexpected, and we want to kind of have that sense that we're always going to define the values right away. Okay, this is a good practice type of thing. So in this case, we're going to put 0 here, but you're going to notice this is bad, but we'll come back to this later, okay? Because it's finalized, well then all students will have the value 0. This is kind of bad. We'll come back to that in a second. Next thing is we want to, you guys said first name. What would be the type for first name?
String.
String, perfect.
String.
So we have first name. And again, we're just gonna put the initialize it to that. We could change this, it's not final. String last name. I'm gonna put that. What else does a student have?
Sex.
Yeah, okay. So a character, sex. And again, we'll define it as, let's say, null because we haven't set it yet. Again, we want to give the default values at all times. What else?
Sir, it can contain grades also.
I
But we
I
can
can't
make
hear
it
you. A bit
better.
louder, please.
So we can make grades also, but we can make another class. It would make more sense.
Yeah, but a student doesn't have grades. What does a student have? This is the key word you gotta understand. What
Yeah.
what does a student has? A has a. Okay, so
So it's sports course enrolled into
okay, good.
or class.
So we could have courses, right? You said courses is enrolled to. You could have more than one. So
Yeah.
again, we don't have a type of course, but we could always create a new
Yeah.
class. Oops,
Age, sir, date of birth.
course. Well, 1 second. We'll just leave course here for now. So attributes, a good word. Well, actually, we'll come back to that. So we could have a course array for the student courses. Okay, and for now we'll keep it to no. So we don't have any values there. Right? So a student could have a lot of courses. What else?
Age, sir.
Age, yeah, okay. Integer age, let's say 0. Or let's say -1. Again, we'll set it up later.
Email ID, address, something like
Home
that.
address.
Okay, so string email, again, we'll set it up. String address, again, we'll set it up. And it keeps on going. Now, if you noticed, all of this is really more of a person thing. Can you tell me one thing that's specific to student? Like courses is specific to students. Anything else? ID, courses, I don't know. Okay, this is fine, let's say. So one thing you'll notice with attributes, you could use this key term has a. You could use that to determine if a student, if this attribute belongs to a student. So a student has a ID. A student has a first name. A student has a lot of courses, right? Or we could say courses. Notice the capital. Notice the plural, sorry. Right? So this keyword has a allows us to define all the attributes that a student should have. And this is important because whenever we create an object, we need to figure out, because here student is something that exists, but sometimes you're going to create something like, let's say you're going to create scanner. You got to define what a scanner should have. You never created a scanner. You don't know it. You never seen it, but you're about to create the blueprint of it. What should it have, right? So these are stuff that you should ask yourself. And this key term has a allows us to allows us an easy way to determine what attributes, properties, fields, class variables, any of these synonyms you want to use that it would have. Is that clear with everyone? So far we have class. One of the main important things about a class is its attributes. And we can easily figure those out if we use the term has a this, has a that, has a whatever. And this is important. We'll come back to this. Okay? And one last thing to note, attributes is also, you could say it's also composed. So you're gonna hear this term. Oops, actually, let's bring that back to here. Defines the object at the top of the class. It's also composed of these, okay? So you'll hear the term composition. This is a key term. We'll come back to this later. So again, notice that a student is composed of ID, first name, last name, sex, age, email. And again, I'm putting all of these synonyms or all of these terms because you're going to see it in the workplace. And again, terminology is going to be a key factor to making you into a professional. If you could talk the talk is when you become whoever you want to become. I'm going to go off topic for a second. Something really cool. One of this company I applied to, I knew nothing about what they were requiring. And I impressed the guy. I went to see them directly and I impressed the guy. And then during the interview, so the guy kept saying, So do you have any experience in this, that, etc.? And to be honest, I had no experience. I never even seen those languages, never even touched any of them. So what I did is I started talking about random stuff that I thought kind of connected to this, and I told them truthfully, well, I don't know this, but if we talk about the composition of blah blah blah, using these terminologies that they knew, the guy kind of was impressed. He's like, yeah, I understand you don't know, you know nothing about this, as you said, but I understand you know everything that's related to that. Anyway, I can't I can't tell you how it went, but to be honest, they offered me the job just at a really low salary. So, but I got a job which I had actually. When they have like this requirement section, I had 0% of that, and that's fun because you could go to anywhere, and until you could show that you're the guy for it, even if you know nothing, they'll give you that, and this is something to learn. Anyway, doesn't matter. Moving on. So this is the attributes that define the student. So this is the first main, out of the three main stuff inside of a class. The attributes define the person. Notice that a student will all have different first name, last name, sex, age, email, address, courses, right? They will all have different values of those, but they will all have those attributes. They will all be composed of that. You all have first names. You all have last names. You all have sexes, age, email, address. Okay? So we're defining a blueprint, not the object itself. The object is not created yet. The second part is, actually I'll start here. So we got attributes. The second part is the actions, the methods. Also use functions because it's methods, but I'm not going to put functions because that's not the correct terminology. So the actions, the methods, what else could I put here? Actions, methods sounds perfect to me. If I have some other terms I remember, I'll put it in. The actions and methods defines the object's actions, what it could do. Defines what the object can do. Right? So this, we'll put it here. So this would be methods, functions, something it could do. So what can a student do? And a good thing to do here is this should be verbs. Okay? It should start with a verb. Right? So what can a student do?
Study course.
Yeah, so a student could study a course. So we would say void study course, and we need to give it a course, right? Which course does he want to study? Right? And again, the body, we don't really care right now. We'll define it later. But whenever a student wants to study, we need to know which course to study. And then you would do the code for studying course, whatever that would be. What else could a student do? Guys, what else can a student do? What do you guys do? Think of all the actions, all the verbs you do as a student, and specific to student. Let's not go outside of that.
Give exams, assignments.
Okay, so we could do, so again, we want to start with a verb. Every time we have a function, a method, we want to start with a verb, and this is going to help us out. Notice attributes are not verbs, they're nouns. They're
Students' grades, sir.
A student doesn't grade. A teacher grades your quizzes and whatnot. So a student could study. Actually, we don't need to have the word course here because it's given inside the parameter. A student could take an exam, right? So I guess take exam.
Submit assignments.
Okay. A student could submit, and over here we'll put assignment, whatever object that is. Let's say, I don't know. I don't have it created yet, but let's say, oh, my computer froze. Give it a second. Sorry, I have Chrome in the background that's running like 100,000 tabs. So And you know what? I'm gonna just shrink the bodies so we have some. We can see this. Oops. So a student could study, a student could take an exam, a student could submit an assignment. Let's create that class assignment, right?
Student can pay a fee.
I couldn't hear that. One more time.
Student can pay a fee.
Oh, paying fees. So actually, that's a good attribute. Their dues, and in this case, what would be the type
Yeah.
for dues?
So it will be double.
Double. Okay, actually, a float would be nice because after the precision, we only need 2, right?
Yep. Yep.
So we don't want to use too much. So dues, and over here we're gonna put it to 0. And over here we could say void pay pay school actually, and we could here say amount. Cool. Notice there's nothing in the body because here we're just defining what a student can do and what a student has. So this says what a student could do, right? And if we notice, let's go ahead back to our main. We used something like a scanner, right? So if I hold down control and I go to scanner, the definition of a scanner. Actually, let me see here, structure. Now, inside the structure, you could see a scanner could do a lot of different functionalities, right? So these are all the stuff that a function that are a scanner, which is the thing to read from an input, such as our console. These are all the stuff it could do. And notice, every function starts with a verb, and so this is a good standard that we want to have. So get me the next float. Has a next float, and just by reading the function name, we understand what that function should do. We don't really care more than that. Okay, and the return type is right after, so we could see this return type. Cool. So this is a really important thing. Any questions about actions, what it could do? And you'll notice all the attributes are here. So it has a buffer, the maximum buffer size, which is finalized, the position we are in inside the scanner, etc., etc. Cool. So again, if you ever like kind of forget things and whatnot, go look at an object that you've been using a lot, such as the scanner, right? And it's good to see what we've used and done so far. So if we go back to students, so our student could study, could take an exam, could submit an assignment, could pay school fees, and for attributes, what defines a student by an ID, by the sex, by the age, first name, last name, email, address, courses, and dues. Any question? So this is how I kind of usually set my classes. Before figuring anything out, I go and I define what it can do by using the key term has a. This is an easy way to figure things out. Secondly, I go figure out what it could do. This object, when it's created, what should it be able to do? In this case, to study, to take an exam, to submit, to pay school. Now, one last thing we want to do, the last important thing of a class, is we want to set a rule for when this object gets created to be able to do something. What do I mean by this? Let's go back to our main here. Whenever we create a scanner, we want to enforce that they tell us where is it scanning. If we don't enter this and then they try to do grabbing the next value and we don't know where it is, we get errors. It breaks the system. It breaks whatever we built. So in this case, we're enforcing that this value comes in, this system.in, that we enforcing to understand where is our source, who is our source, right? So the last thing that we need inside of a class, and we could do that before the action. I usually like to do attributes, the enforcement, and then the action. So in this case, this is called a constructor, and you could think of it as a enforcement of rules. Well, this is not a synonym, so I'll just put it in the next line. An enforcement of rules. Enforcement of rules. So this is to make sure that when the object gets created, it does these things. So makes sure, actually a better word would be, make sure that the object initialization is done correctly. Okay, I don't know how to better term it at this moment. So it's like an enforcement of rules. Make sure that the object is initialized correctly. Initialized correctly. This runs before your object is given to you. So first thing that runs. This is also only done once. Only ran once. And this is done during creation. During creation, which is when the new keyword is set. Right? So if we look back here, this constructor is only hit when the new keyword is done. Again, we can't do it without the new keyword because the new keyword creates the object, and right away we'll call the scanner constructor, and this constructor makes sure that our object scanner is created correctly. Any questions? So constructor is the third thing that's super important, and just like our attributes, just like our action, this is really important. These three things defines a class. And one thing to note about constructor, there's usually a default empty constructor out there, and we're going to see that in a second. So there is an empty constructor that we don't see. It's always there. So if we go back to our main here, actually we never needed the scanner. I'm just going to erase that. So if we go back to our main, you'll notice we could create now a student. So let's call this student Harmanpreet. Okay. Sorry if I use you as an example. So our student Harmanpreet here, if I try to print out Harmanpreet right now, he doesn't exist. Why? Because Harmanpreet has never been initialized. Again, we created the variable, the container, the box of student for Harmanpreet, but we never created Harmanpreet. So to create him, we need to use the keyword new. And then we need to call the constructor. In this case, the constructor is an empty default constructor. This would always be there. Does this make sense? And now, as soon as I create Harmanpreet, if I run this, what should it be showing inside my console?
Address.
Exactly, the address. Again, it's being created on the heap and it's giving you back the address. So here is not actually the student, but the address of where he lives. The address of where he lives. Again, the address is just this, by the way, not this part. I could show you how this works, but another time for another day. Okay, so now that we have our student, this is getting good. Notice that student went from gray to white. That's because it's being used finally. And we're using the default constructor. So the default constructor is not good. Why? Well, let's say Harmanpreet, I try to access one of his attributes and I want to know what his first name is. And I go to access one of those attributes. I have to do Harmanpreet dot. And notice the Intellisense pops up and tells me everything I need to know. So these are the attributes defined with the F. And you'll notice here is the type that's going to be given back to us. And this is important because with this, we know what we're expecting and so forth and so on. And if we scroll down, we'll notice that we have a lot of functionalities there. Okay? Some of them is inherited. We'll talk about that in a bit. So here, I want to get his first name. And the problem with this is what? What's going to be outputted to the screen? Nothing.
Nothing.
Right? Harmanpreet currently does not have a first name. He doesn't have any of these because they're not initialized. Right? So that's the first problem. First problem is when we're given that object, these need to be set. We can't just leave it blank like this. This is unacceptable. We can't have a first name that is blank. Right? We could, because of not setting those, we could come back to having errors. So let's say here I was going to pay Harmanpreet $1,000, but I actually don't know where he lives. The address has never been set, right? He owes, he's supposed to be in this course or that course. I want to put the grade, but he's not in any courses. So when this student object gets created, we want to enforce, we want to make sure that these attributes have been set. Does that make sense? This is why we need this constructor. So here we're going to go define a constructor. A constructor is still a method. So this is a method with the same name as the object, as the class, and has no return type. And this is important. And this is what makes it a bit different from other functions, other methods, but it's exactly the same thing. So this would be called student, and it's a function method, so it needs parameters. In this case, we want to enforce that he has a first name and it has a body. Cool? So now, as soon as I define, notice again, it doesn't have a return type. There's no void, no nothing. This is a constructor. It creates our object, let's say. And the moment I define my own constructor, the default constructor becomes null. The default constructor gets erased. So the moment I create a constructor, my default constructor is gone. And you'll notice here, when I call my constructor student, it says, well, you have an error. I'm expecting one argument, but you gave me none. Right? Inside there, if you want the Intellisense to pop up and tell you what you need, what you require, you do Control P. Parameter Intellisense. I might have misspelled this, but who cares? Actually, I think this anyway, whatever. So as soon as I come in here, I do Control P. It says, hey, I need a first name. All right, I say, okay, the first name is Harmanpreet. But this is not good enough. By the way, the little green squiggly, it just says, hey, you have a typo in the word, but Harmanpreet is his name, there's no typo. So we could ignore green squigglies. Let's go back. First name is not enough. We need the first name, last name, sex, age, everything. We need all of these defined, at least most of them. So we're gonna go ahead and add all the stuff that we require. So last name, character, sex, and if you're really lazy, actually I'll show it to you right now. If you're really lazy, you could also use the the IDE to create the constructor for you. So I'm gonna say right click, refactor. Let's say if we could do. I don't use this, so give me a second. I'm a bit lazy right now. Let's say I select everything and I do refactor, encapsulate fields maybe. No. Okay, fine. We'll do it right now. Or actually, we could have also done it here. So let's say, anyway, it doesn't matter. So let's just create our constructor. So character, sex. Then we have integer age. Then we have string email. Then we have string address. Then we have courses. Courses for now we could leave it blank. And lastly, dues, we could also leave it blank, right? We don't need that for when the student gets created. The stuff that we need is these. Okay? And of course I could add a integer ID as well. Now you're gonna notice something I'm gonna do here. Let's actually, oops, let's close this. So first thing first, you'll notice here now it's wrong because ID I tried to put a string, so this is not good. So let's say this is my first student, then first name is Harmanpreet. By the way, you'll notice there's this gray thing that keeps popping up. This is not me who's putting there. This doesn't exist. This is the Intellisense. This is the IDE to show me, to make me understand that this is the ID, this is the first name. Okay, so this is usually non-existent. Okay, just to make sure you understand. Let's say this main here, actually this student over here. Let's show and explore. If I open the student, again, it's just text files. If I open this, notice inside my constructor, actually, let's open the main. That's the one we were doing. Notice inside main, over here, it just says 1 and Harmanpreet, right? Even though over here, it's showing me an ID and a first name. Right? Do you guys see this? So this is the Intellisense again. The Intellisense is there to help you out. The IDE is there to make your life more comfortable. So again, Control P, it's last name, Harmanpreet. I'm gonna make your last name here. I'm gonna say Apple. His sex, let's say he's male. His age, let's say he's a young, bright, 24 years old. Again, my screen size is a bit small here. His email, let's say he's Harmanpreet he works at apple.com. And his address, let's say 123, who cares? Cool. And again, if your screen size is too big, the computer doesn't care about spacing and whatnot. So one thing we could do is actually bring this in a new line and even maybe bring these into new lines. It's up to you how you do it. Again. Right? Make it whatever that's more legible, more readable for you. I personally don't like this. And for me, it's going off screen because I made it into presentation mode where my stuff is really big, right? So you do it however you want, but the computer wouldn't care so much. Okay? Now having done this constructor, what would it print now when I do Harmanpreet first name?
So it will still print nothing because in the parameterized constructor we haven't initialized a value passed by there. Yeah.
Well, even though the value has been copied to this variable, we don't.
But we haven't initialized.
Yeah, we didn't use it. We didn't do anything. This is our class variable, our field, our attributes, whatever you want to call it, from all of these names. So even though this is coming in, we're not changing this. And this variable that's created here, it will only live within the scope of this constructor. So after this constructor is done, all of these variables are erased. So what we need to do is make it into here. And we have a problem with this though, because they both have the same name. So, sorry, my cat just jumped on me. Anyway, so what we need to do in here, I'm gonna try and do this in one hand. If it becomes really hard, I'll kick the cat away. She wants a bit of petting. 8-hour course is a bit long. So what are we gonna do here is we wanna set the values coming in to our fields, the values that we have for that object. So to do this, we're gonna do ID equals ID, let's say. first name equals first name. And you'll notice we're having a little problem here. The problem is, well, you're gonna see it's all grayed out. Why is it all grayed out? And over here, you'll notice again it's grayed out. That doesn't make sense. I'm using it here. Can someone tell me what's going on?
So we have to use this,
Yes,
like we use in C++.
we have to use the keyword this, but why do we have to use the keyword this?
So because it will point to that these are the class
The current object.
And why isn't it doing that right away?
So actually this indicates that this dot, the name of the variable is class attribute, and the second one is just a parameter.
Yeah, but okay. Well, let me modify my code a bit. Let's say ID. Actually, let's just play with first name for a second. I'm gonna call it FN. Okay. Now, if I do FN over here, it's perfectly fine. Why did I not need to use the keyword this?
Because name is different, sir.
Ah, very good. So the thing that happened is FN and first name are completely different variable names. On the boxes, it's completely different. But when, well, let's say last name, I'm not going to change first name for now. Last name, when I try to make it equal last name, you'll notice that they're both, when I highlight one, they're both highlighting the one inside the parameter, right? If I highlight this one, you'll notice the Intellisense is helping me out. It's telling me that when I have this selected, this is being used here and here. The problem with this is because of the scope. What I mean by the scope is within this classroom, this, let's say again, Harmanpreet, we all know who Harmanpreet is because we only have one Harmanpreet inside this classroom, inside this scope. But actually, there's 20 other Harmanpreets. I have a Harmanpreet in my other course. How do we know which one we're talking about? Well, it's gonna be based on the scope. So in this case, whenever we say last name, we're always gonna talk about the one that's within the scope, the one that got created within the scope, and that is this one, right? So if we want to reference the one that's the object, okay, the one that was created as an attribute, this is the moment we're going to use the keyword this, okay? So in this case, we're not talking about the current scope, we're talking about the current object. We're talking about the current object this constructor belongs to. So this object, right? This is a bit of an English thing. When you're talking about something in your hand, you would say this. When you're talking about something outside, far away, you would say that. So this object is the current object. And we're saying the current object will grab the attribute last name and make it into last name. And we only need this because there is a conflict of names. Notice that now when I highlight it, the last name is highlighting my attribute. And this last name is highlighting my parameter. And again, it's because there is a conflict. There is the same name used in here and over there. And I don't want to make it FN or LN. This is hard to read. If you came in right now inside this video, you would say, what the hell is FN? That doesn't make sense, right? So we don't want to make it weird. We want to be able to use perfect names, something that makes meaning sense. So again, we put the full thing. And again here, we would say this dot first name. Again here, we would say this dot ID. We'll come back to the ID. It's going to give us an error for a second. This dot sex equals sex. This dot age. By the way, if there's something that you're not too sure about, please let me know. Again, these are the stuff you should have came into the class, already understood everything. Nothing should have made any confusion on your part. But again, we don't learn everything perfectly and it takes us time, right? And what I'm trying to do is hopefully we're going to master these parts, the basics. And what we're going to be practicing is more about stuff that's not our foundation and so forth, so on. So we're going to get there. So now if you notice all the first name, last name, look at what gets highlighted when I double click on them, right? And all the attribute levels is being used with the this. And the only reason I use the this is because we kind of have a conflict. I didn't need to use it, but because we're having a conflict, I did. A lot of people tend to just use this all the time. I don't think it's a good way of doing things. You're just enforcing that you don't understand something, or it makes it a bit wordy. It makes it not as clean, right? Seeing all of this is meaningless. We know we're in the object. We're writing everything in here. There's no reason for us to say this all the time. So again, our main goal is, actually let me go ahead and copy that, goals. As always, the goals are important. This is what's gonna define if we get that job or not. Okay, so again, clean, readable code is our main concern at junior level. And you're gonna see I'm gonna add other stuff here, but these are the two main stuff: separation of concern and the cleanness for now. Okay, back to here. So let's comment this error out for a second. We'll come back to that in a minute. Let's go back into our main. In this case, we gave every value. Now, if I print to the screen, what should I be seeing? We should be able to see Harmanpreet because we passed that value, right? So this is cool. So now we enforce that before the object is usable, this is what the constructor is doing. It's setting a rule. It's enforcing that their name and all of this stuff has been initialized. It's been set. Now, the other problem is with this ID. Right now, if I set the ID, you'll notice I get this error. Why do I get this error, guys?
Because ID is a constant, so we can't change its value.
Yes, it's a constant that the moment it's been set, you cannot change it again. However, we do not need to set it here inside the class. This stuff is ran before our constructor. So this part, we could actually erase it. And because it's not set here, the first time it's set for life. So now that I set the ID, I can't go ahead and say this ID equals ID again. It's gonna give me a mistake. The second time is not allowed, right? But the first time, because there's no value set to my final, to my constant variable, now it should be fine, right? Cool, everyone makes sense? And again, the final keyword, we could use it everywhere, right? So these, we could also put it in here, making sure to understand that these variables that are coming in, there's no reason to change them. But to be honest, we're not going to change them as we're just setting them. So this is not really required, right? And they're just temporary variables. Oops, wrong button. Cool. Any questions? No? Okay. So again, now we also have access to Harmanpreet's, let's say, ID, to his last name, and so forth, so on. Cool? Now, next part. This ID is not correct. Let's say we create another student, and in this case, let's pick, who wants to be picked? Wow, you guys are jumping. So let's pick someone randomly, Abin. So this student is Abin. And again, this variable over here, the name here, this is not actually the student, right? I could have renamed this to, let's say, this is student, rename all occurrences, no, rename code occurrences. This is student 1, and this is student 2. This has no relationship with the first name attributes. You gotta understand that. So now I have a student 2, let's say student 2. Over here, his name is Abin. And the rest, I'm gonna just leave it the same, okay? I'm a bit too lazy. And if I print, let's say, if I do a bit of printing here, student 1 info. And you know what? Let's make these a bit cleaner. And what I could do is make it first name. Right, you guys remember the \t? Last name. Sorry, this is the ID. And lastly, last name. And actually, we can move this one up. Okay, so if we print this, we should see the information about Harmanpreet. Looks pretty nice. Student 1 info. And let's go ahead and copy this one more time. And now we got student 2 info, which all of this is student 2. Oops. Any questions? So now if you print, you'll notice the ID is 1, ID is 2, first name, last name, all of that stuff. And Harmanpreet is a brother of Abid because they have the same last name as, let's say. Cool? Any questions so far? Okay, let's go ahead and make this a bit more funky. So now, even though I set the ID 1 and the ID 2 here, there is a problem. The problem is we're relying on human, and humans make mistakes. The computer is gonna make the mistake, but the computer is stupid. He doesn't know better. But the human is gonna make a mistake because, you know, he makes mistakes here and there. So even though we have 2 students, you'll notice that both students have the same ID, right? And that's not correct. How can I fix that? What should I do to fix that? That both students do not have the same ID. They have different IDs. And again, we finalized the IDs, so the IDs can never be changed. So here I can't go and say, you know what, there was a mistake, and student 2 ID should be, look at this, I can't change the value because this has been finalized. This has been a constant. It cannot be changed anymore. So this is not correct. I cannot fix the errors anymore. I gotta make sure that when I'm creating these student objects, I do not make the mistakes to begin with. How can I do this?
So making a static variable next ID and then assign, and then in the constructor incrementing its value whenever the object is created, and then putting its value in ID.
Well done. Congratulations, Harmanpreet. That is a perfect usage of the keyword static. Okay? Now, I'm going to go through the steps of what he just said. Okay? So right now, we have attributes that belongs to each object. So each student will have their own ID, first name, last name. And this is the keyword. They have their own specific one. Now, static, on the other hand, he said to go ahead and create a variable, a static variable, integer, which is going to be called next, let's say, next ID. And we're going to set it to, let's say, starting at 0. And the keyword static in here, what static means, is it's going to make it available for every object that's student. So Harmanpreet has a next ID variable, but so does student 2, which is Abid. And the better fact is that variable is shared between all of student objects, right? So let's see what I mean by shared. So actually, let's go ahead and put a new thing here. So actually, there was a couple things. This represents the current object. Good for when there is a collision of variable names. Now, the other thing we want to add here is static. Belongs to all objects of the same type. So in this case, all of the objects of student, all of them that got created with the keyword new, will have this thing. It exists without the object. So this is always going to be there. Even if we never created a student, we could have, let's say before this, we could have access to it by saying student dot next ID. Notice it's the only thing available to us, the only attribute that's always existing. So if we run this, you'll notice at the top it's gonna say 0. That's the next ID that we have here. The objects haven't been created yet, but it's always there. And again, we could access it from one of those objects too. We could just say student1 dot next ID. Okay, this is fine too, but there's depending on your language, it's not gonna allow you or whatever. The fact is, because it's static, it belongs to the class. They don't want you to make the mistake that it's part of the object. So you need to represent the class here. You need to say student. The class itself has an next ID. Well, actually, it's because I'm not using it. So we're allowed to use it inside Java. Depending on the language, you'll be a bit different. Okay? You'll notice it's giving me a warning. That's the thing that you're going to see. Right? You shouldn't access it by the instance. You should access it by the class itself, because it belongs to the class. It belongs to all of the objects, not to any individual object. Is that clear for the static? So now, because this is shared, with all objects, we could do what he said. First of all, we don't allow outsiders to define the ID, so we're going to erase this. And the value we're going to set here is by saying next ID. Right? And then the next part is we increase it. We could also do this plus plus thing we learn, or I like it better, is we just do it in the next line. We say next ID plus plus, or next ID, plus 1. Either way it would work, okay? So either whatever you do, either this or plus plus, or even added the post increment here, it would be fine. Just have only one of them. So we assign the next ID and then we increase it. And you're gonna notice what's gonna happen. So here we don't have the first variable anymore. So we're gonna erase that. We don't have the first variable. And now whenever we define the student, we don't mention the student ID. The student ID is gonna be defined for us. And at every time we create a student, the ID is gonna be defined, and then the next ID is gonna be incremented. And again, if you wanna go to your code, you could hold down Control and click on it, and you could travel anywhere you want. So if I wanna go to this ID, I could right click on something, not right click, hold down Control, and everything becomes links, right? It's like a URL. So now if we run our code again, you'll notice something nice. And in this case, you'll notice that the IDs are gonna be set without us needing to take care of it. So again, if I create more students, 3, 4, 5, and 6, they're all gonna have different IDs. Let's go ahead and let's give me 1 second. Let's go ahead and put and let's go ahead and put this. Alright, so actually one more thing. Let's put their IDs dot ID. Now if we look at their IDs, they all have different IDs. All the new students. 2, 3, 4, 5, because we started at 0. Any questions? Okay. Do you guys want a break, or we continue and maybe in 30 minutes we do a break? It's up to you.
Break, sir.
Break? Okay. So it's 5:30. Have a good dinner. I'll see you guys at 6:30. All right?
Okay, sir.
All right. See you guys then. Cheers.